So let's move on. The next talk in this session is by Benjamin Grosof. Benjamin, you ready to go? There you go. Thank you.
I'm just trying to get my screen to respond here. Okay. So the title of this talk is Logic Programming in AI, Some Directions. So I think this is related to several talks we had today earlier by Bob Kowalski, Paul Taro, and also the one we just heard from Peter Norvig. So here's an overview, which also functions as an outline. There is an established success of logic programming in AI, and I'll just say LP for logic programming to save syllables through this talk, which is in the area of knowledge graphs and semantic tech, which I was involved in early, starting in the around 2000. And many of the techniques and standards were developed in the period between about 2000 and 2005 or 10. But it took a long time to cross the chasm. It finally did it about a decade later. So since about 2017, it's become a multi-billion-dollar sector in terms of IT spend. And semantic tech here includes not just triples and edges in a graph, but also ontologies and some surrounding rules, which in some cases could get pretty complex. Now, LP as a formalism originally was developed to unify Prolog with relational databases. So LP is really at the heart of structured knowledge management in current enterprise IT and should be in the core of computer science education, in my view, more than it is, especially in the States. Now, there are some applications that are on the more complex end of semantic tech that use expressively extended LP for law and organizational policies or directives. So that's a pretty interesting direction. There's already application pilots, but there's a lot more to do there. Another is combining more tightly with machine learning and natural language. Another is in uncertainty, which is a big challenge when you're as a bridge between ML and LP. Then there's computational scalability and human cognitive ease around things like explanation and also developer or graphical tools.
Benjamin, we're looking at uncertainty slide. Is that what you want us to be looking at? Which is slide number 5.
No, I don't know why that is. I'm looking at, I have slide 2. Let me see if I can fix this.
There we are. I'm seeing slide 2.
Okay, right. So I had an outline slide, just the ones that I just talked about. So I'll get into more detail about each of these. So this area of law and organizational policies or directives is there's a cluster of application domains that have been piloted. And I've listed a whole bunch of them here, so you can probably read them fast and I can talk through them. But finance and legal especially overlap a lot. But then there's health, defense, and e-commerce kind of stuff. And in this cluster of application domains and tasks, the LP is being used for decision support or automation and or associated analytics. And you could kind of think of it as a database on steroids, where you're storing not just facts, but logical rules, which essentially are a whole ton of stored queries that are being composed. That's one way to think about things from a database viewpoint. And one of the things that LP helps to do is to capture complex human knowledge and also deductive reasoning, including notably argumentation, which is quite important in this area of law, policy, directives, and so on, that things often have exceptions, for example. And so one needs actually a fair amount of expressive extension horsepower. For example, in Rulog, which is something I've worked on for Paul Allen and then at Coherent Knowledge, the startup I'm at now, or Bob Kowalski and collaborators work in logical or legal English. And so there are a number of different expressive attributes, which we broadly can group under meta. including higher order syntax, some techniques for bounded rationality, frames and object-oriented, treatment of extended set of logical connectives and quantifiers and heads and bodies and so on. So I have whole talks, even whole conference tutorials about that. Another aspect that's pretty useful in this area is to use restricted NL, which itself can be specified or implemented using LP techniques to a considerable extent. And distinctive strengths of LP in this area are interpretability and explainability, and also assurance or trustworthiness, including in application areas where it's often very important to be highly accurate. So if you're going to give an answer or make a decision, you really want it to be basically pretty high probability that it's correct. So one important direction is to build upon the progress that's happened in this area and bring it to fuller maturity. So another area is what we could call hybrid AI, combining LP as a form of logical knowledge representation and reasoning, KRR, with machine learning, and also with NLP, which is today largely based on ML, and better together. Why is it important to combine them? Well, first of all, because ML is the dog and LP is the tail today in AI research, at least, and largely in industry too. So to capitalize on the progress there's been on ML side of AI and to stay relevant in AI overall. But there are also some pretty specific opportunities, many of them well understood for a long time, for both for LP to leverage ML and NLP and vice versa. So in the direction of going from ML and NLP to LP, there's content knowledge. In the paper, I give an example of an LP externally querying ML for a market forecast as part of making a decision about how much capital to reserve associated with a loan, for example. For control of inferencing, which is an area where there's some early promising results, but hasn't been a ton of work yet, as well as for human-computer interaction, HCI, during querying and also knowledge authoring, as it's called, in other words, editing of things like rules, but also facts and ontologies and so on. Now, in the other direction, LP can provide inferred results that ML and NLP can exploit to, for example, deduce predictions within ML algorithms for hyperparameters or other control of ML, and to generate NL, for example, in dialogue or HCI overall.
Then you have
yeah.
about 2 minutes left.
Okay, so there's some critical needs unmet by ML alone, and uncertainty is crucial as a bridge overall for combining of LP and the ML side. And there's Bayesian, there's fuzzy, there's intervals, there's other flavors, weighting, a la neural nets, ordinal, qualitative, etc. And a big challenge is the computational explosiveness of Bayesian probability when you combine it with LP. The fundamental difficulty has to do with complex upstream conditional dependencies. So fuzzy, or in other words, triangular norms, T-norms as they're known as, works a lot better in simplifying that and conquering that computational explosion. But there's a challenge of having an umbrella semantics and having these things integrate tightly. What is the relationship between fuzzy or truth functionality, as it's called, the T-norms, and Bayesian? And there's a challenge of breadth within KRR to integrate tightly uncertainty and other expressive extensions with other expressive extensions. So there's a need for better theory and semantics, not just implementations and so on. And there's a promising approach I'll just give a quick plug for, to extend PETA, which won the 10-year Test of Time Award at the International Conference for LP, to a system PLOW that combines Bayesian and fuzzy with an interval and bounded rationality-based approach. Computational scalability is pretty critical for this combo. I just think it's worth observing that well-founded is a major advantage over ASP in terms of the worst case and also what I've seen in terms of practical complexity. Concurrency is an opportunity that needs to be seized a lot more. That's more about implementation and engineering effort than really theory or semantics. And finally, in the area of human cognitive ease, that's a major issue today for both developers and end users of LP. People are often not very familiar with LP, including some of the people at this event. Explainability is key for debugging and trust, and it's a strength of LP, particularly well-founded, where you can have a tree-based type of natural deduction plus transformation into NL-based approach that's drillable in full detail, which even non-IT people, business people or end users respond to very positively and feel like they're understanding what's going on. But there are a lot of other opportunities to use, for example, ML and NLP for HCI LP authoring or querying, navigating terminology, supporting team collaboration, leveraging large language models and semantic parsing techniques. There's a lot of other engineering effort required overall in the LP tools and languages to make it friendlier.
Could maybe you conclude?
Yeah, this is the conclusion. So I listed the different points and some of their highlights, and I just want to mention that composability with other data and programming languages. Python, I think, is extremely important because so much of the action in ML and NLP is there. And C also is part of the stack for it, and also as part of the Prolog stack, for example, in XSB, and Ergo AI from Coherent. And, you know, it's important to integrate with tools and systems for not only AI stuff, but other kinds of AI than ML and NLP, but also user and graphical interaction and not various other kinds of non-AI aspects of applications. There's usually a kind of 80-20, 80% non-AI stuff. And that poses a deeper challenge, which I think some of the talks at this event have been starting to tackle, which is how to generalize the essentials and the fundamental approach in logic programming to unify more closely with other languages. That's it.
Thank you.
Thanks.
Thank you, Benjamin. Very interesting.